Hi, welcome back. For this session, I'm not going to open QGIS software, but we are going to talk about a very important topic that affects everything you do within GIS, and that is coordinates and coordinate reference systems. So there are two that you're probably already aware of. The first is latitude and longitude. This is used by any device that uses GPS satellites to get a fix on their location. Any point on Earth can be described using latitude and longitude. So a sat-nav, GPS handset, or a bat detector that logs its position, they all use GPS and all use latitude and longitude. The other is the British National Grid System. So if you have ever used a Ordnance Survey map that uses the British National Grid System, which is geographically restricted to the British Isles and cannot describe areas outside of that. So we're not going to look at the pros and cons of each system or why they're used, what they're good for. You just need to be aware that they do exist because you will be using data from both of them at some point. But if we just take a look at some coordinates here, we will look at how they relate to each other and how you can basically make a right mess if you get them muddled up. So I've just picked a point to the south of Manchester. I live and work in Manchester, know this park fairly well, and I'm going to use it for all of the examples. It's got a nice range of habitats in there that we can map in later exercises. So you can see here it looks like 4 different coordinates. The top 3 are all just variants of the British National Grid System, but the bottom is latitude and longitude. So we're going to look at latitude and longitude first. Actually, no, we're going to look at how, if you put the right coordinates in the wrong system, you end up going very wrong. So if we put 0, 0 into the British National Grid System, so with eastings and northings, I've already plotted this in earlier, it basically will bring you to the start of that system, the very bottom left corner, 0, 0, which is here. If you accidentally input those coordinates, so as the right coordinate 0, 0, but you put that into a system that's designed for GPS coordinates, you would end up off the coast of Ghana to the south in the sea. So you may have the right coordinates, but put into the wrong system, it's going to really mess things up for you. But first of all, we're going to now just have a look at the two systems and what the coordinates actually mean. So yeah, let's take a look. So going back to the Manchester Park, we've got latitude coordinates, decimal numbers, starts with a 53, the latitude, -2 for longitude. So if we go to Google Earth, which will give us a good view of the whole planet. So latitude starts at the equator, runs north and south in these parallel bands. These just show each 10-degree division, so going from 0 at the equator to 90 degrees at the top, and they are either north or positive degrees. If you go south of the equator, you will get degrees south. These can also be expressed as negative degrees, and they also go to 90 as well. Whoa, spinny. So let's just recenter. Longitude is the same. Longitude starts at the prime meridian and goes east and west in these parallel bands. Again, if you go east, you've got degrees east or positive degrees. If you go degrees west, then they can also be referred to as negative degrees. So if we look at the British Isles, most of it is contained within latitudes of 50 to 60 and longitude of so we've got, if we look down at the bottom here, we've got +2. If we go all the way past Ireland, that is 11 west or -11. So all of the latitude longitude coordinates, if you're working in the UK, should all be kind of restricted to that area. So what those degrees actually mean, so if you're looking at 50 degrees latitude, if you start at the equator, drill a hole to the centre of the Earth, then drill back out again and pop out on this line, the 50-degree line, the angle that you create at the centre, so going in and back out again, if you measure that angle, that'll be 50 degrees. Again, if you come out at the 10-degree line, you go in from the equator to the centre and back out again, and that'll give you a 10-degree angle. So these are all just decimal degrees. Sometimes you get it represented as different format, degrees, minutes and seconds, and it just looks weird. So if you look down the bottom right there, you have these numbers, so it's degrees, minutes and seconds. All that, it's not time measurements, they're still distant measurements, but what you get is if you come down to the 1 degree, where's the 1 degree north line, it's basically between 0 and 1, that's split into 60 equal bands, which create the minutes. Each minute band is then divided into a further 60 bands, which then give you the seconds. So it's basically just subdividing into 60 rather than the kind of subdividing into 10, which would give you then the pure decimal degrees. Don't know the origins of that. If you want to read up on it, feel free. But for mapping purposes, it's not important to know the history, just that it can appear in different formats. So if we now go back to this map, I'm going to touch a little bit on what the SJ means, but not really too much. If we move to the easterns and northings, this is how we would input British National Grid coordinates into a GIS system. We wouldn't be using the SJ followed by the numbers. We would always using the XY, easterns and northern coordinates. And what these are, literally, are measurements of meters. So basically what this is saying is this point here is 385,000 meters to the east of the origin of the British National Grid system, which is down here. So basically if you go 385,000 meters, it'll take you to here, which is in line with that. If you then go 391,000 meters north, that'll put you roughly in line with it there. So it's literally just X and Y coordinates starting from the 0, 0 point down here. What the letters mean, and again, don't really know the full history or why it's done. I think it's to do with making it easier when you're actually using paper maps to find the right map, because they'd usually be marked with the, like the SJ, the numbers first. The whole British National Grid system is divided up. It's actually divided up into 500 kilometre squares, given a single letter starting A at the top left there, and then going all the way down to the bottom right here. But the system actually starts at SV because there's no land mass further west than that, and it doesn't go any further than TW because, again, it restricts it to the actual land mass of the country. These letters, there are charts that show you the conversion of these, and you basically just take the letter, get the numbers, split them in half and stick them on the front of the pairs of coordinates. So if we go back to here, sorry, what's SJ? I'm sure SJ is equivalent to 33. So if we go back here, we can see that with the X and the Y coordinates, it starts with a 3, for each of the pair, and that's the SJ, which makes the 33. So SJ separates out 3 in front of the 85304, which gives you the 385304, and then 3 in front of the 91853, which then gives you the 391853. So basically that is the two coordinate reference systems that you should be using. I'll get into them a bit more detail of how they're actually set up in QGIS once we start using them. But for now, I think that should give everyone an understanding of what latitude and longitude is, and also what the British National Grid System is as well. So thanks for that.